Hello, welcome to the lecture series of the partial differential equations. This is the fourth lecture. It's on the solutions of partial differential equation. Today, in this lecture, we're going to discuss the homogeneous partial differential equation. Let us consider homogeneous partial differential equation. When we say it's an homogeneous partial differential equation, it has got only one independent variable and the dependent variable. Let us take one simple problem how we're going to solve the homogeneous partial differential equation. For that, solve the equation dou square z by dou x square plus, sorry, it's not plus, it's a minus a square z is equal to 0 under the condition z is equal to 0 and dou z by dou x is equal to a sin y when x is equal to 0. Now see there, it has got the given differential equation. When you observe this, it has got only one independent variable x. Even though it's a partial derivative, it has got only one independent variable and it is an homogeneous differential equation. To solve this here, we'll go ahead to write this differential equation as an ordinary differential equation, because whenever you come across with the only one independent variable, then the partial differentiation becomes an ordinary differential equation. That is, this is dou square z by dou x square minus a square into z is equal to 0 can be written as it's a d square z by dx square minus a square into z, which is equal to 0. Then this is a homogeneous differential equation, or that too it's an ordinary differential equation. As we have done in the chapter 2, this equation can be written as this is capital letter d square minus this is a square into z, which is equal to 0, where the capital letter D is nothing but d by dx. Since it is only one independent, we are writing it as an ordinary differential equation. And to solve this type of the differential equation, we have learned that it is a complementary function and the particular integral. Here, the right hand side will be 0. Therefore, the particular integral will be equal to 0. But the complementary function, to find the complementary function, you have to write the auxiliary equation just by replacing the capital letter d by m. And finding the solution of this quadratic equation here, this is m is equal to plus or minus a. Then whenever the roots are real and distinct, the complementary function cf will be equal to some constant c1 into e to the power of ax plus c2 into e to the power of minus ax. Since the right hand side of the equation will be 0, particular integral is 0, the complete solution is z is equal to c1 into e to the power of ax plus c2 into e to the power of minus ax. Now, we have the given equation which is under some conditions. The conditions will be to find the values of these arbitrary constants C1 and C2. Let us see the conditions. What are the conditions? Let us say the first condition is, that is z is equal to 0, dou z by dou x is equal to a sin y when x is equal to 0. First we take the z is equal to 0 as the when the x value is also equal to 0. Let us take it as the condition z is equal to 0 when x is equal to 0. For this here, if I substituted this equation or these values in the equation, then we have it is the 0, which is equal to C1 into e to the power of 0 plus C2 into e to the power of 0. E to the power of 0 is 1, therefore I can write this as C1 plus C2 will be equal to 0, or I can write this as the equation as C1 value will be equal to minus C2, or C2 value is equal to minus C1. The next thing is here, we have a one more condition, that is minus dou z by dou x is equal to a sin y when x is equal to 0. That we consider it the second condition. To condition 2 here, when z is equal to 0, or sorry, it's when x is equal to 0, dou z by dou x will be equal to a into sin y. This is what the condition it has been given. See here, this is the dou z by dou x is equal to a sin y when x is equal to 0. Let us use that condition. In this, to substitute the value of dou z by dou x, we need to find out the dou z by dou x from this equation. For that here, if I find out here dou z by dou x, it's a dou z by dou x will be equal to C1 into e to the power of ax. E to the power of ax differentiation is e to the power of ax into a plus C2 into e to the power of minus ax into minus a. Now we know that dou z by dou x is equal to a sin y when x is equal to 0. Just we substituted a into sin y here, which is equal to C1 into a into e to the power of 0 plus it's a minus a into C2 into e to the power of 0. Or I can write here a into sin y will be equal to e to the power of 0 is 1. Here I can take the common factor a here, a into C1 minus this is C2. Now this a and this a will get cancelled. C1 minus C2 will be equal to sin y. But earlier we have determined the one condition C1 is equal to minus C2. We'll just substitute the value of this is C1 is equal to minus C2. This is minus C2, which is equal to sin y. Or I can write it is minus 2 into C2, which is equal to sin y. Or the value of C2 will be equal to minus 1 by 2 into sin y. Once if I know the value of C2 as minus half into sin y, the C1 value can be written, C1 value will be equal to minus of C2. Therefore, I can write this value of C1 will be equal to, this is half into sin y. Now we know the value of C1 and C2. Let us substitute in this solution. Here it is the general solution we have here. This is in this solution. We'll try to substitute it. For that here z is equal to C1 means here it's a half into sin y, into e to the power of ax, minus C2 is minus half into sin y into e to the power of minus ax. Just we are substituting the values of c1 and c2 in the general solution. In this general solution, then we'll get the solution of the given partial differential equation, which is a homogeneous under the condition when z is equal to 0 and dou z by dou x is equal to 0 when the value of x is equal to 0. This is the way we're going to substitute, or we'll find the value of the partial solutions of the partial differential equation. Now here in this method, we are just writing the partial differential equation in terms of the ordinary differential equation, and then we use the complementary function and a particular integral to solve it. Now let us take one more problem of this particular kind here. Let us say here solve second one, solve the equation dou square z by dou x square minus 2 into dou z by dou x plus 2z is equal to 0, given z is equal to e to the power of x and dou z by dou x is equal to 0 when x is equal to 0. This is as usual same as the previous problem. See there in the given equation here also we have only one independent variable with respect to that z here dependent variable. Therefore, I can directly write it as this equation as the ordinary equation. It's a d square z by dx square minus 2 into dz by dx plus 2z, which is equal to 0. You just think of this as since the given PDE is homogeneous, you can write it as an ordinary differential equation. Now this can be converted into this is d square minus 2d plus 2 into z, which is equal to 0. The next thing is here also the right hand side will be 0. The particular integral will not exist, that will be 0. The complete solution is only the complementary function. To find the complementary function, we write this equation, the auxiliary equation, m square minus 2m plus 2. I think it is correct. It's m square minus 2m plus 2 is equal to 0. Now we'll try to find out the solution or the quadratic equation, solution of this quadratic equation. For this here, m value will be equal to minus b. We use the formula of minus b plus or minus square root of b square minus 4ac divided by this is 2a. Either you can use calculator to obtain this solution. Now which is equal to, here I will show you it is, this is 2 because minus of minus, it's a minus here, plus or minus the square root of minus 2 the whole square minus 4 into a value is 1 and the c value is 2 whole divided by 2 into 1. Now which is nothing but it is a 2 here and this is 4 and this is plus or minus square root of 4 minus 8 whole divided by 2. Since it is a complex root here, it is 2 plus or minus 2i whole divided by 2. Or I can write this is 1 plus or minus I. Once the roots are complex, the solution, the complementary function will be in this particular format. This is CF is equal to e to the power of the real part, that's a e to the power of real part, that is x1 into x into some constant c1 into cos the imaginary part, it is x, plus c2 into sine x. This is our the general solution. That is, since the particular integral is 0, the complementary function itself is a full solution. Z is equal to e to the power of x into c1 cos x plus this is c2 sine x. Now, this solution has to be determined under the conditions, the given conditions. Here the given conditions are, this is z is equal to e to the power of x and dou z by dou x is equal to 0 when x is equal to 0. Let us use the one by one condition. For this here, the first of all, when x is equal to 0, when x is equal to 0, the z value is equal to e to the power of x. This is the first condition. We have the z is equal to e to the power of x into c1 cos x plus c2 sine x. Now, if I substitute this, the z value is e to the power of x, which is equal to e to the power of x into c1 into cos of 0 plus c2 into sine of 0. Sine 0 will be equal to 0, cos 0 is 1. Therefore, e to the power of x is equal to e to the power of x into c1, and this term is 0. And this e to the power of x and e to the power of x will get cancelled. The value of c1 will be equal to 1. This is the value of c1. Now, we have to use the second condition, that is, which is given as, this is, see that here, dou z by dou x is equal to 0 when x is equal to 0. This is the second condition. For that here, that is when x is equal to 0, dou z by dou x is equal to 0. To use this condition, we require dou z by dou x. Let us go ahead with this is finding that this is dou z by dou x, which is equal to, see here, to find the dou z by dou x, here it is a product rule. The first function e to the power of x into differentiation of the second function c1, the differentiation of cos x is minus sine x. I will write the minus c1 into sine x plus c2 into sine x, nothing but the cos x, this second function, plus e to the differentiation of the first function, e to the power of x is e to the power of x into the second function c1 into cos x plus c2 into sine x. Now, we have to substitute this condition, dou z by dou x is equal to 0 when x value is 0. When x value is 0 means e to the power of 0. Wherever sign is there, this term and this term will be equal to 0, But only the thing here, this and this will remains. For that here, see, let us say this is 0 plus this is c2 plus e to the power of 0 into c1. Now, see that this is c2 and c1 will be equal to, or c1 plus c2 will be equal to 0. Or I can say the c2 value is equal to minus c1. Now, once we know the value of c2 as a minus c1 and we get the value here, it is c2 is equal to minus 1. Now, we substitute both the values in the solution here. This is the one z here. I can write this as z is equal to e to the power of x into c1 means 1, it is a cos x, it is c2 is minus 1, it is sine x. And this is our complete solution of the given partial differential equation, which is a homogeneous under the given conditions here. And this is the way you have to solve the homogeneous differential equation. You please watch this video and try to solve the questions which are of the same type which is given in the question bank. Okay.